And welcome again to another episode of the Southwest Climate Podcast. Mike Crimmins.
Hey, Zach, I really liked how you drew that out too. That was really nice.
I'm practicing, we're on our 110th episode here. I'm getting better. They say it takes training, I'm just a slow learner.
Right, we're getting close to getting this right.
Well, it's good to see you virtually. And hopefully,
I know we're still doing this over a year now, still virtual.
Right. And I feel like the end is nigh for virtual, which is really quite exciting. I know U of A is making preparations to be in person for the fall semester. So yeah, looking forward to that.
Yeah.
So I'm going to affectionately dub this the How Bad Is It Drought Report. What do you think about that?
I like it. I'm going to guess it's bad. Did I just scoop you?
No, I think that was a rhetorical question. I think you need the answer. Mike, I'm recalling prior to the new year, we made some predictions about what we thought 2021 would look like. I could be misremembering, and I probably made some really bad predictions, but I think I made one good one, which is that as we continually progressed from the winter to spring, we'd see an escalation of news stories about the direness of the drought. And lo and behold, there's a number of headlines that have come out over the last couple of months and more recently.
We're geniuses.
Yeah, that was okay. That wasn't a hard one to predict. But let me read a couple of the headlines. Okay, so this one's from Vox. As a mega drought persists, new projections show a key Colorado River reservoir could sink to record low later this year. Okay, CBS News. Western U.S. may be entering the most severe drought in modern history. Another one, why the intense U.S. drought is now a mega drought. And a Washington Post article, amid a record dry April, a late week storm won't quell severe drought in California in the West. And those are just a few from a variety of different sources. So yeah, so this is going to be the drought report. So let me take us through what I think we'll get to today, Mike, and feel free, as you always do, to rein us in here. But, the winter's over for the most part. Like anything that comes now forward is more an oddity than anything. And maybe there's some precip for us early next week that remains to be seen. Probably not for southern parts of Arizona and New Mexico. But for all intents and purposes, the winter is in the books. And so let's place the winter in a historical context. And then I thought it's worthy of us to interrogate this question of how bad has it been? Has it been a mega drought? Is it a mega drought? So let's go there. And then let's end with some thoughts about the foresummer and what are some emerging impacts of, the last two really dry and relatively warm seasons.
I like it.
Nothing you want to add to that?
No, you're so prepared. I don't want to get in the way of that.
Okay. Before going there, I wanted to make a sort of advertisement here. And we talked a little bit about this at the end of our last podcast about a game that we're going to offer and do a trial of related to the monsoon fantasy. So I figured we'd start this time with this plug because I just don't know how long people are going to stick around on this podcast. and plus, this is a little bit of optimism. What we want to do is we want to engage interested people in guesstimating what the monsoon precipitation will be at 5 different cities each month. And so basically what people are going to do is we're going to have this really cool web interface that are set up that you can log into. It'll be sort of like, we just went through March Madness. We'll have a running tally. So you'll score points each month based on how close your guesstimates fall to the actual precipitation, and you'll accumulate points. We may even have some prizes, still working on that. Not sure if we're going to have funding or not, but at the very least, this will be a way for us to engage with interested people and see how good you guys are at forecasting the monsoon. We're right now building this infrastructure, the online platform, but if you don't want to miss being informed of how this is going to go and creating a username and profile, then sign up for CLIMAS's newsletter. And we're going to, we'll be talking about it here as we go forward and a few other outlets Certainly will be making people aware of it through this CLIMAS's newsletter. So you can just search CLIMAS, which is actually CLIMAS, CLIMAS. So just search that, Google search that, and you'll be able to find easily a way to sign up for a newsletter. So yeah, we'll be coming back and giving more updates on this, but I just wanted to let people know it's going to be super cool. And we road tested it last year in a much more informal way, and we're trying to make this a little bit more gamified, if you will. So let's get to it, Mike. The last month, not a whole heck of a lot to talk about. It's been roughly 40 days since there's been measurable rainfall in the low deserts, and about a month for rain and snow in northern parts of Arizona and New Mexico. So has it been as quiet as that would suggest?
It's been quite delightful, if that's the right word. I mean, and again, you remember from the last podcast, I used the term the best of the worst. I still kind of feel like that's kind of carrying through, because we're kind of predictably drying out. We're seeing not much precipitation, maybe a little bit from storm systems that have been passing by to northern Arizona, northern New Mexico. We've been in a really active weather pattern. We haven't seen the precip with it, but we've had a lot of these storm systems moving by and warming us up really, really briefly, but then cooling us down. So we've kind of had this roller coaster, which is really pretty common for April. And so that has brought a lot of the wind, but it's also kind of moderated the temperatures. So you just look at the last 30 days or so, and the temps they were really warm early on in April. But if looking at the last 30, 60 days or so, they're a little bit above average because of that brief warm stretch. But overall, the temps have been moderate. So if it's not going to rain, I at least don't want it to be super hot. And, that heat can really exacerbate fire conditions. So I think that what we've seen over the last 30 days or 40 days or so has been pretty run of the mill for what we'd expect this time of year, especially in the recent decades. And I'm not complaining too much. Definitely would have wanted more precipitation, but again, not expecting much this spring.
So you mentioned that the temperatures haven't actually all been all that warm for the most part. I mean, if you look at March, for example, this is I'm looking at the most recent month of data. So we're at the end of April here. So, but just looking at March, pretty much below average for most of Arizona and the western part of basically pretty much most of the West.
Yeah. I mean, the Southwest proper, I'm looking at the Westwide Drought Tracker maps, looking at January through March. So even the last couple of months, like you said, doesn't have the last couple of weeks, but Arizona and New Mexico are pretty close to normal. It's been a little bit cooler off to the east, and a lot of that was contaminated by the really deep freeze event that happened earlier in the wintertime. And then around, Arizona, kind of, maybe leaning a little bit above average because of a couple of warm-ups. But again, temps have been moderate because we just haven't seen that really strong, pronounced ridging that would bring in those temps in the spring and really heat us up early, like we've seen in past springs. Just hasn't really manifested yet.
Yeah, and when you look across actually the West, and just going back to the rainfall picture, I mean, the dry conditions are pretty much ubiquitous around the West. I mean, there's a few spot places that have above average here and there, but for the most part, this is a region-wide last month of pretty low rainfall. You don't really find a coherent region that has experienced greater rainfall. So was there just what was accounting for that? Were the storm systems just further north? Did they drop down further to the east?
It's been, the storm track it's been entering through the Pacific Northwest has been slightly wetter than average. Is that correct? It does not show up as that being the case in the last 30 days. So in the last 90 days, the far Pacific Northwest parts of it were slightly above average. Okay, so the last month, the storm track has been basically storm systems moving through the Intermountain West, but they've been inland trajectory. So they just haven't had any moisture to work with. And that moisture source really decreases as you get further and further into the spring. There's just the storm systems themselves get slightly warmer, so they can't carry as much moisture with them, because you're getting more of that difference between relative, the relative humidity basically goes down as the storms warm up with the same amount of moisture. It's easier to do when the storms are really cold. The middle of winter, it's easier to make the precipitation. But as you get further into the spring, it warms up, and so those storms become less effective. The northern Rockies have seen a little bit more precipitation from these storms, but we're on the dry side of it. So we end up just getting the cool down and the wind associated with those storms.
Yeah. What's the lingering influence of the waning La Nina there, do you think?
Yeah, maybe. And again, this is the thing that it's still going to have to go back and kind of look at this year and try to understand a little bit more. But some of that, I think we talked about this the last podcast, but the ENSO blog had done a couple of really nice posts on how unusual the La Nina pattern really emerged across the Pacific Ocean as far as circulation patterns. It didn't look canonical. It didn't look like the past events that we would have seen. So you can look at like the winter of 2011 into the spring of 2011, really deep drought for sort of Texas, Great Plains, New Mexico, reached into Arizona. Looking historically, that La Nina pattern looked very, very classic. When you average a bunch of La Nina patterns, it looked very similar. And so it was a intense magnitude La Nina. We also had a moderate, to strong La Nina event this past winter, but the way the atmosphere responded was really different. And so we certainly got the dry part of it, and there probably is some part of the circulation pattern that matches it, but a lot of it didn't match. And so as it's been waning, we kind of see the same weather pattern we've seen for the last couple of months persist. It's just even a touch drier, because we did get some precip out of some events, and at least, that one in January, that was a multi-day event, one in February, and then one in March. And still the northern parts of the Four Corners, like the Southwest proper, is still getting, spits of rain here and there. But again, it's just not very wet.
So I remember last podcast, we were talking about the dryness, and, it takes a couple days. We usually do this on Thursday or Friday. So it takes a couple days for the podcast to actually drop. And then I think if it wasn't last month, it was a month before that it dropped when we were talking about all this dry conditions, and during a time in which it was raining. And so there is some indication, Mike, that we may get some relief. But
I think you ruined it because you said it out loud. I mean, I think it's like, if we would have just stuck with that, and, people didn't wash their cars, or they did wash their car, that'll make it rain, right? I always get that backwards. But yeah, I think maybe the fact that we brought it out in the open, we've ruined it.
So the models are picking up on this. They've been actually, I think you were saying this, they've been actually declining in their confidence or the magnitude of the event, particularly for the southern parts, like for Tucson area and that sort of thing. As you go up to northern Arizona, Flagstaff area, Albuquerque, it seems like there's a little bit more confidence in rainfall. Is that more or less so in other words, can we say that it's less likely that by the time this pod drops that there'll have been a little bit of late April relief in southern Arizona, and maybe some in the northern parts? Yeah, I'm just trying to cover our bases here.
Exactly. Yeah. No, the models are notoriously optimistic at longer time scales, and especially in the springtime. They'll often show really wet events for parts of the Southwest, and always super skeptical of them. And as you get closer and closer to the event, they usually dry out. And so I think that this one is probably going to be on the same trajectory. It kind of makes sense. It's just harder to pull off. And again, in a warming climate, it's harder to pull off these events unless there's a lot of really cold air intersecting with a decent moisture flow. And those are harder to come by. And they're really hard to come by in late April as opposed to even early April.
It's not going to change the picture.
No, it's not. There was no drought buster on the the forecast scope for next week. The best it would do would be throw down a little bit of precip, increase the relative humidity, maybe temper fire danger briefly, or at least give a break, to crews that are kind of positioning or maybe working on fires. That in its own right is, I think, beneficial. But quickly, what happens on the other side of these events is it warms up quickly again.
Well, they also bring wind. So I mean,
they bring the wind, yeah. So if this event has some clouds, some relative humidity and a little bit of precip, that's a way different wind event than a dry, sunny wind event for a fire. So this is, if you're going to get a wind event, take this kind.
Yeah, so it will come of no surprise to listeners who regularly tune in that we've kind of been trending in the trajectory of deep, severe drought. And, basically from December-ish, maybe January, but probably in December, we were pretty confident that it wasn't a matter of if we were going to be below average rainfall for the winter. It was just a matter of how much.
Yeah.
So here it is, putting this winter, the last 6 months, into some instrumental historical record. So this is over the October through March period. Does not account for April. Like I said in the beginning, April has been basically dry everywhere. Maybe there's been, I think, Mike, maybe there was a little bit in Cochise County and that sort of thing, but few and far between rain events for April. But anyway, this picture for October to March shows that, I would say, if I'm doing my eyeball spatial average right now, that something like 75% of Arizona is in the bottom 10 percentile. And then the other 30% is somewhere, it's in the bottom 33rd percentile. So the winter was, again, it's not historical here. And, I can actually put some numbers to this. So for Tucson, yeah, so let me give a different numbers here. This is a slightly different period. So this goes back to mid-October, but actually incorporates part of April as well. And so if you look at Tucson, it's been the seventh percentile. Phoenix is the 9th percentile. Part around Flagstaff, like Winslow area, 5th percentile. You look at like Las Cruces, the 22nd percentile. Albuquerque, the 13th percentile. So not historically dry, not like the driest, Mike, but this is not a good picture anyway that you spin it in terms of the entire winter rainfall.
So okay, so let me put my little my spin on this too, with just a couple of numbers here too. So I think you're spot on, Zach, and that's the thing is, like, I was really worried that we would repeat some of our more recent drought periods that were La Nina driven. I'm thinking of like 2018 was more recent. So like Flagstaff ended up getting in the October through May period in 2018, Flagstaff got 5.7 inches, which is way below their average, which is about 13 inches for that October through May period. They have 8.3. So that's like a couple inches better, and they're probably better sitting than any part of the state.
I'm sorry, what was that? What part of the state?
So that was Flagstaff, right? And again, we've had a couple of localized events that really kind of pounded Flagstaff. And again, this is all contextualized within a terrible winter, right? So I'm talking about, this is bad, as Zach said, but it could have been worse, I guess, right. Is what I keep coming back to. And like Albuquerque, October through May is at about 1.3 inches right now, which is worse than 2018, where they got 1.5, but it's better than 2013. So, right. It's like, yeah, maybe it doesn't matter that it's slightly better than some of those other terrible months, but it seems to me kind of important. But I'm looking at like Tucson, which I think you mentioned here, 1.4 inches so far, October through May, which is just slightly worse than 2011, which really surprised me. I thought 2011 was so much drier than this year, and here we are. And this is on top of that record dry monsoon. So I think that those two things working together do make this kind of where you're going with this convo. Yeah, well, that I think is, we talked about this last podcast. Like, I think you use the words, it could have been worse, or, not as bad as it could have been. But maybe it doesn't matter at this point because it's so bad. Like, it was so bad. And then it was like this winter was really bad. And I still believe that the couple of precip events that we have gotten have taken the edge off of what could have been really, really bad and really nuked a lot of vegetation and maybe set us up for a even worse stream flow situation, which is terrible in its own right.
Let me try to put this into even a longer historical record, because I think you can't decontextualize. I mean, you can just look at the winter, but the fact that it follows on the heels of the historically dry monsoon season adds an important part of this story. So if you combine those two, we're looking at across Arizona in the lowest 10 percentile of the historical record, with some areas experiencing its driest in the historical record. So if we include the monsoon, it's an unprecedented or near unprecedented picture. And the monsoon was worse than the winter. I mean, you mentioned, like, I think the winter, Mike, for Tucson is, the third or fourth driest on record. I think that's like the 6th or 7th percentile because it's not 100 years. I was curious, right? Like, so going back to the headlines that I read in the beginning, like, that are referencing like megadrought, which we can talk about in a minute. But I was curious, like, how deep of a drought is this, or how unprecedented are these back-to-back seasons? So fortunately, we have some of the best paleoclimatologists in the country at the University of Arizona who do some amazing work on tree rings and other proxies to try to piece together precipitation that goes further back than just, the last 70, 80 years where we have actual like rain gauges and thermometers. So I asked Kevin Anchikaitis, who's in the geography department.
Shout out, Kevin.
Yeah, this was awesome. So there's this data set that has been created from something like 2,500 tree ring reconstructions. It's a gridded data set that, they do fancy statistical tests to reconstruct precipitation in both the winter and summer seasons over the continental U.S. That goes back basically to the Common Era, beginning of the Common Era. So the database, it's the North American Seasonal Precipitation Atlas, has 2016 years in it, again from tree ring records. So he queried that, and he wanted to know, okay, what was the frequency of just having a dry summer followed by a dry winter? So this is below average or below median for a summer, then followed by a winter. And I think, as you would expect, it's not that uncommon to have those consecutive seasons. About 27% for the Southwest area experience dry summer followed by dry winter. All right, so we had basically a less than 10 percentile summer and a less than 10 percentile winter. So what were the chances in the last 2016 years, or how many years in the last 2016 years did that occur? Dry summer, very dry winter. 1% of the time. So that's where we are. We're in that 1%. So by these measures, in the historical record, Mike, like it's very uncommon. And then if you go back 2,000 years, it's very, very uncommon. So that adds a little bit more context to, I think, what we just came out of.
Yeah. So Zach, I built a little tool online that I've shared with you, and I've used it for sort of training on the standardized precipitation index, but I can do a similar analysis. So I queued up just to follow on what Kevin presented there too. And so this is using gridded climate data Prism, and it's available monthly from 1895 to present. And so I queued it up for just, I think what you did. So I chose July, August, September as the summertime, and I can calculate the SPI for that. And then I chose January, February, March as winter, and I could choose some other timescales. But just to your point, in the historical record, based on this gridded data set, a very dry summer followed by a very dry winter has happened twice in that record. And the 2 years that happened were 1924 and 2001.
Wow. Well,
so it's rare, I guess, is what we're trying to say.
Stumbling over words here. So that record that I was talking about, the further back you go, maybe the more uncertainty you built in, because there's just fewer tree ring records. So if you subset the data from 1400 to 2016, so a shorter record, 616 years for this area, Yeah, the less than 10 percentile summer and less than 10 percentile winter was 16 years in that 617 years, which is basically 2 in 100, which is basically what you just came up with. So there's some consistency there. So we're not in uncharted territory, but for all intents and purposes, we might be. And if you add in like the fact that it was likely much warmer over the last two seasons than it was in the periods that we're referring to in the way past, then it is unprecedented in that sense.
Yeah, and I think that convergence of this is where the natural variability, climate change kind of collide, and so we can have it like we're just talking about instances of these combinations of events that are very, very rare in the historical record at the same time that it's warming. So it's clearly warming, and it is warming due to anthropogenic climate change. And so that converging with this rare event makes the impacts that makes them different than even some of the past events. So, like the 1924 event that I just talked about, in that situation, you'd expect there not to be, probably impacts on vegetation and soil water stress and, water resources that you'd see now.
So there's a phasing here. It's a dry. Most people in the literature talk about the sort of anti-phasing, dry, wet, dry sort of thing. But what are some of the controls on would there be anything that would sort of control a dry versus a wet, dry sort of pattern?
Is that a rhetorical question? That's a real question, isn't it?
It's a real question.
Well, I mean, I think in the literature we've been picking at that, and there's a hypothesis that's been out there in the literature and is been used that the summer monsoon season and the onset of it is controlled by local land surface heating. And so as the sun gets higher in the sky and you are trying to build the subtropical ridge north, having dry soils and low snowpack allows the synergy of having that warm land mass help the subtropical ridge build in. And then the opposite would be the case, if there was a lot of soil moisture and a lot of snowpack, that would hinder the advancement of the subtropical ridge to the north. And that subtropical ridge is really important for the onset of the monsoon and really sustaining and bringing on that precipitation. So that's one.
But that's a wet.
Oh, I'm sorry. You're right.
That's a wet dry.
The anti. Right. Yes, that's right. So that's the anti.
People have talked about the anti-phasing quite.
Yes, you're right. I'm sorry. So in the literature, and I think it kind of intuitively too, is that the dry, wet would have something to do with some larger scale forcing, probably related to sea surface temperature anomalies, right? So that's the phasing of ENSO, La Nina, El Nino, its impact on the atmospheric wave pattern, and then how that then relates to not only producing precipitation or lack of in the wintertime, but then how that translates into the summer. And it's not as clear to me and how that all sort of fits together. And in the literature, it's even a little bit murky as well.
Yeah, I think it is murky. So I looked up this cool study by an ex-U of A graduate student that I actually went to graduate student with, Dan Griffin. He put together this really cool paleoclimate reconstruction that we've talked about in the past, but doing so for just the monsoon season. And then he coupled that with what had been done previously on the winter season. And he found that, and this is for anti-phasing or opposing signs. So this would be wet and dry. And he found that the frequency of wet dry is kind of randomly distributed through time. I mean, he doesn't talk about wet or dry explicitly, but it kind of makes me think that maybe it'd be the same thing if it's randomly distributed for wet dry, then maybe it's also sort of a random process going on with dry. I don't know. I'm just speculating here. I don't know.
No, I think that's what, what's been really helpful with some of the paleoclimate studies is that it's really dragged out past the contemporary record. And this is why it's always so helpful to have the paleo. Part of the conversation here is that some of the things we're observing in more recent times may or may not be all that unusual or stable mechanistically. And if we don't understand what the mechanism is and it's statistical, then you've got a small sample and it may be, just unusual with respect to the sort of longer term variability. And I think that that's probably what's going on. I mean, there's modeling studies like on the anti-phasing, if, the wet winter leading to dry summer and vice versa, that do suggest that land surface heating is in effect. But the tree rings, the paleoclimate study suggests that it's not, that it's more of an emergent property in the historical record. So then it's like, well, there's got to be some other mechanism at play here. And some of those studies on that paper, there's a couple other that we were talking about, Zach, that really do suggest that the larger scale circulation patterns that are being forced by tropical sea surface temperature variability are really important in this whole discussion. I think that's probably right too.
So I was trying to get a beat on, the monsoon fantasy game by then trying to figure out like, well, what's the monsoon? What's the monsoon going to be like this summer? So I had Kevin also run.
Oh, wait a minute. That's why. You just let it out, man.
Well, no.
You thought it was just sort of a collegial exchange of information and ideas, and no, you're running a racket. That's what it's all about.
Well, so I only did it for one part of this, which is I was curious what the chances of a dry summer followed by a dry winter followed by a dry summer would be. And again, this is only for so this is for the full 2016 years. I'm gonna see if you can guess this. How many times in this drought atlas or precipitation atlas do you think dry occurred? Less than 10 percentile. So this again would be a failed monsoon.
I bet it's happened like once.
Happened more than once.
Really?
Yeah.
3 times?
Happened more than 3. I'll give it to you. 13.
13, really?
Yeah, that's 0.6%. I mean, we're talking like real low chances here. So I don't know what that means.
Actually, okay. Yeah, that makes sense. Based on what we were talking about in some of the papers that we were just talking about as well, is that the runs of dries could certainly, they could even be, they could emerge by chance, just in natural variability as well.
Yeah, and some of the bigger ones, or some of the times that occurred was in the 1600s, which, to come back to this word megadrought, Mike, that's where part of, I think, the megadrought story comes from. So in like the mid 1600s, there was a string of like 8 consecutive seasons of really below average. Well, these are in standard deviation units. So there was, so in the 1600s, these are in standard deviation units, but there's 5 consecutive seasons actually that were below 1 standard deviation unit. So in the low, what would that be, Mike? That would be in the lower 40th percentile? No, lower.
1 standard deviation?
Yeah, so lowest 17th percentile, right?
Yeah, right.
So that happened. 6 seasons consecutively. So, but that's where part of this idea of megadrought. So to turn back to that idea, Mike, do you think we're in a megadrought?
No. Okay. So
what the heck is a megadrought?
Well, okay. So, and I think this is it depends on where you're at and what you're talking about. And so I end up, where I live is in all of these, I think, shorter timescale variability, and like in my work, I work with like farmers and ranchers and more on kind of landscape scale impacts, related to fire variability and that kind of stuff. And so I'm always thinking about seasonal precipitation as well, if it's showing up or not. And so you can look at drought at different timescales. And so, we have to remember that a year ago, last winter was actually a decent winter for much of the Southwest, not everywhere and not perfect. And it wasn't, a smackdown wet. And in the last 10 years, we've had a handful of good monsoon seasons and, clearly 2 poor ones in a row, and quite a bit of, a couple of decent winters as well. So I'm always thinking about that seasonal variability.
Right.
And if you kind of move that out to longer time window and you move that along, it's definitely been kind of bumping along below average. And so it kind of just depends on your time scale. So the water resources situation is going to reflect the slower time varying situation, which I think we're seeing playing out in the reservoirs. But we also have the shorter time scale variability that has been kind of going up and down. And so we have extremely acute short-term drought conditions that are kind of on the longer term now, because, and again, this is what's short versus long. Maybe it's still short if we're thinking about basically 12 months now. 12 months of acute drought conditions is really what we've got. Because if you go move that 12-month window backwards, it improves. So right. To me, it's like we have this longer term drought situation extending back to the 90s that on average is below average conditions that I think does stress stuff over time. But we've had some rebounds in precipitation at shorter time scales, which ecosystems and vegetation do respond to. The caveat to all of this is that it's warmer. So drought also has this sort of feedback with precipitation and soil moisture. So it's just harder for precipitation to be effective under these warmer conditions.
But this term megadrought, I think it's kind of an interesting term because it is catchy enough. I mean, you saw you heard in the headlines of some of those news articles, the use of it. So it's gotten a lot of traction, and I was just interested in its roots.
Can I say one thing too before you move into that? Because I think what you're going to say is really important, but I just want to make sure I clarified. It could be a megadrought in terms of like looking at the paleo records. You've got this extended period where you on average is below average precipitation, even though you've got short-term rebounds in precipitation. But I think calling the current drought situation, the acute conditions, a megadrought is not quite right, because it's acute short-term conditions that aren't part of it's a seasonal drought. It's one seasonal drought crammed with another seasonal drought for the Southwest.
Right.
Other parts of the West, California is a completely different dynamic, and I don't want to lump us in with them.
That's partially where I was going to go. I mean, I think it's, first of all, the term is not precisely defined. I traced down the roots of the use of the term. As far as I can tell, it originated, and people at U of A will know about this more than me, in part because two people from the University of Arizona it was first mentioned in their paper. So this is Connie Woodhouse and Jonathan Overpeck. Overpeck used to be here. He's now at University of Michigan, but in a 1998 paper, I believe this is the first mention of it. So I tried to track it down because I was just interested in like, well, how do we think about megadroughts and whether or not the last two seasons that people are insinuating is part of a megadrought is such a thing. And so let me give the language from the paper in which it was first mentioned. These authors, Woodhouse and Overpeck, state, quote, during the 13th and 16th centuries, there is evidence for two major droughts that likely significantly exceeded the severity, length, and spatial extent of 20th century droughts. The most recent of these, quote unquote, megadroughts occurred throughout the Western US in the second part of the 16th century. So the point here is that basically a megadrought would be defined in relation to something that just exceeds the severity, length, and extent of what we've experienced in the historical record. So that can be construed in a lot of different ways, right? So what severity are we talking about? What length are we talking about? What's the spatial extent? I think all of this is just to say that it's a word that I think has gained quite a lot of traction in both in the academic literature. Actually, there's been an increase in trends of the use of the word. I also did that quick analysis, but more so in, I think, the headlines, in part because it's pretty darn catchy.
It's clearly in that early work, it's long droughts on average, right? So you have to, you're thinking about something time varying, and it's got to have it's a slower moving process, and it's got longer extent, it's longer duration anyways. I guess that's what I'm struggling with, is that, so the term mega, I think, is talking about the intensity and duration over long periods of time, which I think translates most readily in the Southwest to the water, the relation. So it's like, what are other systems that integrate climate over long time periods? It's typically water trees, I think at that, which is why I think they kind of match up and they work well together. But we have these sort of fast varying elements of seasonal climate that are also important, you can have droughts come and go, even in a mega drought, that's at a longer time scale at these, slower varying components of it. So you can be in drought and out of drought at the same time, depending on what you're talking about and what you're looking at. And so my other point here too is that I think what's been confusing as part of this conversation is that we've now moved this temperature aspect into this, which is the concept of aridification, which I think is really useful and important. And I kind of come back to that droughts start and they end. So those mega droughts in the past had beginnings and end based on those tree rings. But if we're now going to call drought conditions that are both precip anomalies, but also increasing temperatures mega droughts, they're not mega droughts anymore. They're permanent droughts because we're in a, it's getting warmer. And so you have this aridification. So it also, I think, confuses because decadal variability is expected to continue. As best as we know right now in climate projections, decadal variability will continue, which means that there are extended drought periods and pluvials in our future, meaning that we could swing towards wetter conditions with more frequent El Nino activity under warmer conditions. So then, if now is a current mega drought with an extended drought period, it will have an end to it, even under warmer conditions, as long as we kind of tease those two things apart.
Right. Yeah. And the most recent pluvial that you were mentioning is, basically preceded the really dry conditions in the early 2000s. So we had a protracted period of actual wetter conditions, and a lot of the reservoir systems were, at relatively high levels in comparison to now. And yeah, we've been for the most part, a more persistently drier time in the last 20 years.
Yeah. So I use drought indices a lot. I mean, it's kind of the tools of the trade for me. And one of them I was talking about standardized precipitation index, just by itself, just precip. So it's not including temperature in it. You can use this at a multi-scalar window. And if you use something like a 5-year window and kind of move that across time, it dampens out all of the seasonal variability. It shows up really, really nicely. There was a very, very wet period in the 80s. And then the more recent drought period, which you just said is about 20 years. Well, it was interesting about 2015, which was the hyper mega global Godzilla El Nino that I'm still sort of scarred by. It was a slightly wetter time for Arizona, just slightly, not imperfect. And you started to see some of those longer term drought metrics actually sort of rise up a little bit. And then we've fallen off on the other side of that with more recent La Nina activity, 2017, 2018, and then this past year. So, we're kind of in this noisy part. And again, I'm not saying that drought's going to end in the next 2 years, 5 years, or even 20 years. We just don't know. We don't know how to anticipate those transitions. But if it's a drought, it actually has to end. But it'll be trying to do that in warmer conditions, which changes the water balance side of the equation.
Right. And it also means, yeah, exactly. It also means that it'll be more arid you could have an arid period where the precipitation is relatively
plentiful. Right.
Yeah.
Yeah. I mean, it'll be a different system. So the way the water moves through, and this is where I just think we've got to really get our heads around what this looks like in the future. This is where I feel research should really be kind of pounding on is what does returning to some, and again, we don't know when this will happen, but some higher level of precipitation under a warmer climate, how much less effective is it? Or is it, scaling with that?
Well, so there's some measures of that where they try to scale stream flow. I mean, it's a little bit more complicated, but try to scale stream flow based on, temperature changes. So what does 1 degree, an increase in 1 degree of global or regional temperature mean for stream flow? And boy, I just read this paper. It was in 2020 from Science. And I think it's something like, nobody quote me on this, but I think it's something like 8-9% of decline in stream flow.
Yeah, no, that's I think it was Millie.
Yeah.
Was one of the authors. Right. So, but there's an even more, there's a whole litany of papers now that are building, and Connie Woodhouse and her team just did a paper out this year same sort of refinement. And it's, it's order of like high single digits to low teens scaling with a degree. And this is decreases in stream flow in the Colorado River because of reduced snowpack. So
right.
I want to make sure that I'm clear here that it doesn't mean we're going to have more water in the future as it gets wetter. I think it's the opposite of that. The warming,
as it gets warmer,
as with decadal variability, the expectation that we could phase into a wetter period, based on El Nino activity, I think that the question is that, and some of this research is suggesting that the snowpack really suffers. So the water systems would even suffer in a future climate as well as it was wetter, because you're managing rain rather than snow.
Right.
So, but I'm thinking more on terms of like ecosystem response, local water resources, those kinds of things. So it could be a really kind of snarled, messy, future with all of these sort of uncertainties.
No, there is certainly a lot of complicated nonlinear feedbacks associated with this, particularly with water, because stream flow, because stream flow itself is filtered through another medium, which is the land surface. And when you're talking about precipitation, it's one thing. When you're talking about stream flow, it brings in a whole bunch of other important processes as well that are impacted both by precip and temperature. So there's a whole bunch of interactions that occur. But I think your point, just to emphasize it, is a good one, which is that yes, we will see relative periods in the future of higher rainfall and relative periods of lower rainfall. I think we can feel fairly confident in that, right? Like climate is non-stationary, and and there is a lot of variability within it.
Yeah, and I think there's a lot of uncertainty in the projections, going forward. There's that suggestion of it, the mid-latitude jet retreating north, and there's a lot of uncertainty in the ENSO side of this. But largely, what you see with the climate projections in the Southwest proper is just this widening band of uncertainty rather than trend. It doesn't trend up and it doesn't trend down. It just has like this wide band of uncertainty around no change, which to me suggests that, like what you just said, is that with that information, it suggests in the future that we'll have wet periods and dry periods, but it'll be a warmer climate.
I mean, boy, I mean, if you looked at the regions in the US, like, is there a harder place to sort of project than the Southwest for future? It's more than just rainfall, but to me, it seems like, we're not just talking about, wintertime westerlies and the impact of ENSO on those. We're also talking about the monsoon season, which delivers, 50% of our rainfall. And boy, we've got a long way to go to feel pretty confident of that. And oh, by the way, that is also seemingly partially wrapped up in sea surface temperatures in the Pacific, although maybe not to the extent that the winter is, but still, I mean, there's two distinct seasons that have a whole bunch of uncertainty associated with it.
Absolutely. And, some of this has been in the literature for a while, and it's emerging more. The Atlantic sea surface temperature in the tropical Atlantic and the Atlantic they appear to have an impact on the monsoon season circulation as well. So it's like we've got, the thing is so wired together and snarled together, which is why I think we have so much trouble, because like you said, two different seasons. The seasonality of the precipitation, as well as the interannual variability component, have made this a very noisy climate place, for, probably since the last ice age. You're seeing in the paleo work. And then now, as it's changing, it makes it really hard to anticipate hydroclimate wise where we're going. But it's getting warmer. That's the piece of information it's like we can count on. And how do we use that in a noisy climate?
Well, I think that's a good point to end this segment on. Let's quickly turn to thinking about, as we've contextualized the summer and winter, now we're entering into this, traditionally, hot and dry period before the monsoon ramps up. This is our time of year where, it's pretty windy, fire season's reaches its apex right before the monsoon comes in. Obviously, it's only going to get drier. And so, drought conditions won't improve. Mike, what are we what are we seeing so far from on the impact side of things that you can speak to? Like, we've had a few fires, but maybe not so many yet, but we certainly expect that to be maybe a characteristic of this upcoming forest summer. No,
there's definitely a concern, and it's totally rightly placed. I think our whole, the whole lead up of the sort of drought discussion, and then the more recent wind activity. So that convergence, the Southwest, National Interagency Fire Center seasonal fire outlook has all of the Southwest with the expectation for above average fire activity, which, is, I think it's a pretty safe forecast. So just looking at the Southwest Coordination Center website, there are 555 year-to-date fires in Arizona and New Mexico, and that's 19,000 acres. So it's, that's a lot of little fires. There was a fire where, this is such an Arizona thing or such a Southwest thing, where the Gila riverbed caught on fire and burned very close to a town. I shouldn't
be laughing. That's just funny the way.
No, I know it's not
the riverbed.
Yeah, it's not funny. It's very because it was, it burned down a bunch of structures in central Arizona, but it's a very Arizona thing because it's a river without water in it, and I think it burned through tamarisk, but they had large tankers on it very quickly. And then there was another fire in southeast Arizona that's actually burning right now that they very quickly had large tankers on too. So there's a lot of pre-positioning and a lot of resources down here to kind of jump on stuff. It is April and it's windy. We've had a lot of red flag days and we've got these really dry conditions on the ground. I think the temps moderating and a little bit of rain next week could really help tamp it down briefly, but it really is sort of mid-May to late May, and then that push between Memorial Day and the monsoon start. Memorial Day is kind of traditionally a lot of fire starts happening right around then with people out camping and those kinds of things. So I think you mentioned this earlier, Zach, is that there's an expectation that we're probably going to see forest closures and fire restrictions to try to get ahead of the ramp up and human caused starts in May and June. But we've got a long stretch here, so it's April 23rd, and 2 months from today, do you think it'll be humid and raining everywhere?
Boy, I hope so.
I do too. But I just remember too many June 23rds where that.
Oh, it's unlikely. Hopefully there's signs that it's on its way. In terms of the fire season, I mean, some of the risk will depend on just how fast it warms up too.
Yeah. This windy stuff could be really problematic. If the wind keeps going into May, that will be one thing to contend with and deal with, which could be really problematic. And the flip is that the ridge starts to build in and we get into kind of more stagnant, but much hotter weather. So then you've got this situation where you either have these sort of wind driven fires, like we saw with the Wallow fire, or you can have the ones that are plume dominated, like the Rodeo Chetasky. And those are two kind of different weather conditions in the background, both not helpful for fires. And so there's a risk of both of those kind of going forward.
Even in a high risk, you still need some ignitions, and half the ignitions come from lightning. So
they do, but they don't typically occur till the Bighorn fire, if you remember, it was really strange early June kind of stray storm lightning strike that sparked off, and then it was just like poor timing. Like if it hadn't done anything, maybe that fire wouldn't have started, and then we had such little lightning later, it might have we might have just gotten through the season.
Right. That was the Mount Lemon fire last year, right?
That's right. Yeah. But I think it was 2017, 2018, deep La Nina. It was very dry fall, winter. Some of the driest for, I think, some of the northern Arizona stations, but there were a ton of forest closures that spring, and the fire activity, I think, was really kept down because of a lot of those management decisions.
Yeah, I mean, I think, we've talked about this before, but fire is one of those complicated systems that involve both people and the environment. But there's no doubt that a drier period before is just sort of sets the stage for higher risk. It doesn't necessarily mean that risk will come to fruition. Like I said, it could just be that there's not as many lightning strikes, cloud to ground strikes this year as in the past. I mean, that's possible, but certainly the stage is set, I guess, for elevated risk, and we're seeing that in those in those forecasts. So I'm sure that the fire folks are pretty keen right now about the next couple months.
Absolutely.
Anything else, like in terms of impacts? I mean, one thing that we didn't mention that I don't want to dwell on too much here, but I alluded to in reading some of the headlines in the beginning was just that the Colorado River, for the first time is projected to be below sort of one of its like metrics for Lake Mead, water levels at Lake Mead that then trigger what they call these shortage sharing agreements. So that's actually gained a lot of sort of headlines. We don't have to delve too much into that, but it is worth saying that the headlines relate to the forecasts that were made in April that suggest that by June, the water levels in Lake Mead will fall below this important elevation, 1075, which is the meters above sea level, the water level elevation. But that really the key forecast is made in August. And if the water levels are projected to be below that 1075 for January of 2022, that's what triggers the shortage sharing agreement. So that's all to say that that's going to be a story that's going to be evolving. Nothing in the next few months are going to change that picture. What could change that picture is what the people think or the forecast for next winter will look like. And we really can't get into that at the moment, Mike, just in part because this is the time of year where it's the most difficult to forecast the winter season. It's called the spring predictability barrier that we've talked about before. But I did want to hit just before closing here, Mike, the monsoon forecasts from the Climate Prediction Center are still a little bit bullish. How do you feel about that?
I'm trying to guard against wish casting because I feel like I want it to be true. I'm not being objective, I guess, at this point. It, for the second month in a row, has shown above average, a lean in the odds towards above average precipitation for July, August, September. I really hope that's true. I'm a little worried that it's maybe bullish.
Yeah, I don't buy it, but I'm hoping.
I guess that was a long way of saying I'm not convinced yet either. I'm not convinced yet either.
And also, I mean, these forecasts, like there's slight shifts in the odds. So, when you open the hood of them, they're quite difficult products to use. I mean, but so aside from the numbers, they are indicating some enhanced chances of probably an earlier onset of the monsoon, maybe related to the low snowpack that allows the monsoon ridge to sort of encroach further. But my feeling is that there's not a lot of confidence around this, although it is surprising that for the second month in a row that these models are saying that. I'm just not confident that there's a ton of skill in the monsoon forecasting at this moment.
Yeah, the National Multi-Model Ensemble has certainly the take on it this month is it's not particularly wet across the Southwest, but it's dry across the Great Plains. It's got this sort of classic signature where if the Great Plains are, and it really does, it speaks about the position of the subtropical ridge. If it's in a good spot for Arizona, it's typically dry for the Great Plains and kind of vice versa, which we kind of saw a little bit last year and the previous year. So the models are suggesting, the dynamical models are suggesting some good ridge placement for sort of northern Mexico, Southwest proper, at least average precipitation, which is certainly fine. I mean, I would be happy if that worked out. I like you said, I'm not totally sure yet.
Let's go with it.
Yeah, I that's just it. It's just like I feel like
why not, right?
I don't know if I can emotionally take it though to get all hyped up for that, and then to have your whole thing about 4 dry seasons in a row from the Paleo Record, Zach, that was crushing.
Yeah. Well, hopefully, we'll see who's optimistic for the monsoon fantasy.
Yeah, that's right.
We'll see who's pessimistic.
You know where I'll be.
Yeah, and we'll see how people's guesstimates change by the month. So
yeah,
get ready. Really I'm excited. I'm excited for that.
I know we should actually make people bet mid-May. I mean, that's really getting out there.
Yeah, it will be interesting to see collectively how so skillful is a term of art in forecasting, how skillful the collective forecasts are for the monsoon. And wouldn't it be cool? I think it would be really cool if there was, some collective consciousness skill in these monsoon forecasts, maybe tapping into sort of some sort of deep-seated geographical knowledge. I don't know.
I had the vision of the Matrix where everybody had that plug in the back of their head. It sounded like some evil genius scheme that you're coming up with there, Zach.
Yeah, well, we're going to test that. All right, Mike, I'm looking at my computer percentage here and I'm at 5.
I wondered why you shut your camera off. So I expect you better wrap it up there.
Yeah. But that was good. I think we covered all the bases. Let's put this last, 12 months of failed monsoon followed by a pretty severely dry winter in the rearview mirror. And let's hope for a relatively mild foresummer and then a booming monsoon.
Yeah. Safe, no big wildfires, and then onward to the monsoon.
All right. Well, thanks, Mike. I appreciate the time and looking forward to hanging out sometime soon in person.
All right. Put our glamour shots on the web too.
All right. Thanks everybody for listening.
Thanks, Zach.
I'm going to have to hold for something. I got somebody at my door.
I think we should leave this in. A little bit of music here.
Thank you. I have landscaping.
Life goes on.
All right, let me back up really quickly.